Hi everyone, welcome to our presentation for the ME Summer project. And our project was to develop a reinforcement learning based microrobot control methodologies. As an introduction, the basic problem, like I mentioned, was to develop control methodologies to manipulate a group of microrobots in a local potential field. And the goal of this for this summer was to first explore the possibility of implementing reinforcement learning for the control problem, uh, implement and improve upon the current motion planning methodologies, and also to develop a simulation testbed to test out these different approaches for motion planning. As a little background to the problem, the microbot move on what is called the UMS platform, which consists of 11 by 11 grid of coils, with each coil divided into a 5 by 5 grid of points. And each point allows for a distinct set of directions that the robot can go into. And this becomes the crux of the constraints that we will be working with for our problem. For the beginning of the summer, we started with designing the simulation testbed, which consists of the 11 by 11 grid that I mentioned before, as well as a randomly spawned group of obstacles that the robot needs to avoid. We started with implementing single agent planning algorithms such as A star, D star, with A star being an extension to the classic Dijkstra's algorithm for finding the optimal path for a graph problem, and with D star being an extension to A star, where it works more optimally for a dynamic environment. For example, for a pre-calculated path, if an obstacle moves into that path, D star handles that problem more effectively and recalculates a more optimal path faster than A star. D star light again acts as an extension to D star, where it's algorithmically simpler, and also which allows us to improve upon that and play around with it better than D star. We then moved on to the big problem, which was multi-agent planning. This video gives you a crux of what the problem is about, where the robots need to allow for for the optimal paths of other robots, so that each of those robots can get to their goal locations without colliding with other robots. This led to us implementing what is called as the conflict-based search algorithm, which first plans out the motion for each robot using something like A star algorithm, and then finds whether or not these paths have conflicts between them, and then solves for them individually. I'll then now hand it off to Danny to talk about his part.
Hi, now I'm going to talk about how my work during the summer different from Fagan's and how our work will be incorporated together and contribute to our final goal of this project. So firstly, I start with the single agent path planning as well. So these two figures show the A star and the RRT star path planning as I set up the obstacles starting position and the final position. The algorithm will compute the possible path connecting those positions. And based on this, I focus more on modeling our robot to have a simulation closer to reality. Instead of describing our robot as a point, I describe it as a rectangle, and I will put more effort to investigate it. So here I want to talk about the design of our micro-robot from the previous work. As you can see in the left figure, the body of the micro-robot is painted to red and blue, and we add a magnet to shift the mass center from the body center, and also add trailer and side supports. The figure on the right shows our micro-robot pushing the parts to assemble a P shape. So in order to fully understand and model our robot, I work on the dynamic part of this project. So this figure shows the dynamic of the robot with trailer bypassing the obstacles. It's one of the progress that we understand better about the effect of the trailer. And also I research on the dynamic of the wheeled robots, as our robot is omnidirectional and its behavior will be different from fixed or steerable wheel in the last case. And this figure shows what I have done to trace the movement in our experiment. so that the path is recorded and can be compared to analyze our dynamic model. So future goals. In short term, we want to incorporate the micro-robot dynamics into our path planning algorithm model. We also want to develop ROS-based control system to realize this agent plans into physical movement for other micro-robots. And in the long term, we want to look at the advantages and disadvantages of the current AI-based approach and potentially move into the machine learning-based approaches. And thank you for listening.